In this video, we'll be looking at the concept of constant speed. A GPS unit or app on a smartphone can show you the speed of your car. But GPS technology only measures your position, not your speed. So how does it figure out your speed? It measures the position of your car periodically and uses this information to estimate your current speed. In this video, we'll start to think about how this actually works. We're going to consider a car driving along a straight section of a highway after setting its cruise control. We'll use this picture to represent the car's trip. Watch the car moving along the road. What do you notice about the motion of the car? There are several measurable attributes of the car's trip which we might be interested in. One of them is time since turning on the cruise control. I'll show the car's trip again and use a red bar to represent time. Specifically, the length of the bar will represent the amount of time that has passed since the car turned on its cruise control. Another measurable attribute of the car's motion is the distance it has traveled since starting the cruise control. I'll show the car's trip again, this time also adding a blue arrow to illustrate the distance the car has traveled since starting the cruise control. As you watch, think about how the blue arrow, the amount of distance the car has traveled since starting the cruise control, is growing in comparison to the red rectangle, the amount of time it has been traveling. In order to compare how the amount of distance traveled and the amount of elapsed time were growing, we can measure each of these quantities. I'll show how the amount of elapsed time increases again and mark off 2-second intervals to measure it. So the car traveled for 4 2-second intervals. Next, I'll measure the amount of distance the car has traveled since starting the cruise control. This time, I'll use arrows to show the amount of distance the car travels in each 2-second time interval. Each time interval has an amount of change in time, in this case, 2 seconds. Also, each distance interval has an amount of change in distance, in this case, 59 meters. Now, let's think about how these time intervals correspond to the distance intervals. These black lines indicate how each distance interval corresponds to a time interval. The key feature here is that the size of each distance interval is always the same, no matter which 2-second time interval you are looking at. How would this picture have changed if we had used 1-second intervals instead of 2-second intervals? I'll show the car's trip again, this time splitting it into 1-second intervals. Each time interval has an amount of change in time. In this case, 1 second. Also, each distance interval has an amount of change in distance. In this case, 29.5 meters. Now, let's think about how these time intervals correspond to the distance intervals. As before, these black lines indicate how each distance interval corresponds to a time interval. The key feature here is that the size of each distance interval is always the same, no matter which 1-second time interval you are looking at. Now, we've seen 2 examples where the size of each distance interval is always the same for each time interval. Another way to say this is, for any fixed amount of change in time, the corresponding change in distance is constant. In the first case, for every 2-second change in time, there is a 59-meter change in distance. This means that for any 2-second change in time, the car will travel 59 meters. So, the speed of the car is a constant 59 meters per 2 seconds. And this is what it means for the car to be moving at a constant speed. Another important aspect to constant speed is knowing the car travels 59 meters for every 2 seconds allows us to know how far the car travels over any other period of time. For example, if the car travels 59 meters in 2 seconds, the car must travel 29.5 meters every second, or 88.5 meters every 3 seconds, or 14.25 meters every half second. So in this case, another way to describe what it means to have a constant speed of 59 meters per 2 seconds is that the car's change in distance in meters is always 59 halves as large as the corresponding change in time in seconds.